In today's lesson, we will learn how to find the distance between two endpoints. In our first example, we are going to find the length of line segment AB in our diagram. To find the length of the line segment, we first need to locate the line segment on our coordinate plane. Now that we've located our line segment, we need to identify the coordinates of each of the endpoints. To do this, we are going to start at the origin, which is right in the center of our coordinate plane, and then we're going to count over and up until we get to A to figure out the coordinates for point A. So if we start at the origin, we have to go 2 units to the left, which is -2, and 1, 2, 3, 4, 5, 6, 7, 8 units up. That gives us the coordinates -2, 8 for A. We're going to do the same thing with point B. If we start at the origin, we would have to count over 9 units to the right, and we would need to count 8 units up. That gives us the coordinates of 9, 8. Now that we have identified the coordinates of our endpoints, we can begin to find the distance. In each pair of endpoints that we're going to do today, either the x coordinates are going to be the same or the y coordinates are going to be the same. Once we identify which ones are the same, we are going to ignore the coordinates that are the same and focus only on the coordinates that are different. In this example, point A has an x-coordinate of -2. Point B has an x-coordinate of 9. These numbers are not the same. Now let's look at the y-coordinate for both. The y-coordinate for point A is 8. The y-coordinate for point B is 8. These are the same. Remember, we're going to ignore the coordinates that are the same and only focus on the coordinates that are different, which in this example would be our x-coordinates. Now that we have our coordinates that are different, we need to decide what we're going to do. Looking at the two numbers, if the two numbers have different signs, meaning that one's a positive number and one's a negative number, we're going to have to add the absolute values to find the distance. If the two numbers have the same sign, meaning they're both positive or they're both negative, we're going to have to subtract the absolute value. The x-coordinate in point A is a negative number. The x-coordinate in point B is a positive number. So because of this, we're going to have to add the absolute values to find the distance. The absolute value of -2 is 2. The absolute value of 9 is 9. 2 plus 9 is 11. So the distance between the endpoints A and B is 11 units. Let's move on to our next example. In this example, we're going to find the length of line segment BC. First, we need to locate line segment BC on our diagram. Once we locate the line segment, we now have to find the coordinates of each endpoint. If we start at the origin, to get to B, we would have to count over 9 units to the right, and we would need to go 8 units up. That gives us the coordinate 9, 8. We're going to do the same thing with C. To get to point C, we would have to count 9 units to the right and 2 units up. That gives us the coordinate 9, 2. Now that we have our two endpoints, we can begin to find the distance. To find the distance, we have to figure out, is the x-coordinate the same or the y-coordinates the same? And then we're going to ignore the same coordinates and focus on the coordinates that are different. So in our example, the x-coordinate for B is 9 and the x-coordinate for C is also 9. The y-coordinate for B is 8 and the y-coordinate for C is 2. So we're going to ignore the coordinates that are the same and we're only going to focus on the coordinates that are different. And in this example, our y-coordinates are different. Now that we have our coordinates that are different, we're going to figure out what to do with them. If the two numbers have different signs, we have to add the absolute values. If the two numbers have the same sign, we're going to have to subtract the absolute value. In our example here, we have a positive 8 and a positive 2. Since they're both positive, to find the distance, we have to subtract the absolute value. The absolute value of 8 is 8. The absolute value of 2 is 2. 8 minus 2 gives you 6. For our next example, we're going to find the length of line segment CD. To find the length of line segment CD, we first have to locate line segment CD on our diagram, and then we need to identify the coordinates of each endpoint. To do this, we're going to start at the origin and then count over and up until we get to C. For coordinate C, we would have to count over 9 units to the right and 2 units up. That gives us the coordinate of 9, 2. For coordinate D, we would count over 9 units to the right and 5 units down. That gives us the coordinate of 9, negative 5. Now that we have our endpoints, we can begin to find the distance between these 2 points. First, let's look at the x-coordinate for each point. The x-coordinate for C is 9, and the x-coordinate for D is also 9. The y-coordinate for C is 2, and the y-coordinate for D is negative 5. Remember, we're going to ignore the coordinates that are the same and only focus on the coordinates that are different. So 9 and 9 were the same, so we're not going to focus on the x-coordinates. We're going to focus on 2 and negative 5. Now that we have our different coordinates, we need to decide what to do with them. We have a 2 and negative 5. Since those two numbers have different signs, meaning one's positive and one's negative, that means we have to add the absolute values of both of these numbers. The absolute value of 2 is 2, and the absolute value of negative 5 is 5. When you add that together, 2 plus 5 gives you 7. So the distance between C and D and the length of line segment CD is 7 units. For our next example, we're going to find the length of line segment BD. If you would like to try this example on your own, pause the video here, work out your answer on scrap paper, and then unpause the video when you're ready to learn the answer and go over the steps. First, we need to locate line segment BD. Once we have the line segment located, we need to find the coordinates of our endpoints. Start at the origin. To get to coordinate B, we would have to count 9 units to the right and 8 units up. That would give us the coordinate 9, 8. Same thing for coordinate D. Starting at the origin, we would have to count 9 units to the right and 5 units down. That gives us the coordinate 9, negative 5. Now that we have identified the coordinates, we can begin to find the distance. Looking at our x-coordinate for both points, B, it's 9. For D, it's also 9. Looking at our y-coordinates, B has an 8 and D has negative 5. Remember, we're going to ignore the coordinates that are the same and focus on the coordinates that are different. In this example, that will be 8 and negative 5, our y-coordinates. Now that we have our coordinates, we need to decide what to do with them. 8 is positive, negative 5 is negative. So if you have one negative number and one positive number, the signs are different and you have to add the absolute values. The absolute value of 8 is 8. The absolute value of negative 5 is 5. 8 plus 5 gives you 13. So the distance between B and D, and the length of line segment BD would be 13 units. For our next example, we're going to find the length of line segment EF. If you would like to do this one on your own, pause the video here, work it out on your paper, and then unpause the video to go over the steps and find the answer. Here's line segment EF. We need to identify the coordinates of each of the endpoints. Starting at the origin, to get to point E, we would have to go 2 units to the left and 5 units down. That would give us the coordinate -2, -5. To get to point F, we would have to go 2 units to the left and 2 units down. That gives us the coordinate -2, -2. Now that we have identified our coordinates, we can begin to find the distance. Starting with our X coordinates for both points, we have a -2 for point E and a -2 for point F. Looking at our Y coordinates, we have a -5 for point E and a -2 for point F. We're going to ignore the coordinates that are the same and focus on the coordinates that are different. In this case, it's our Y coordinates. Now that we have our different coordinates, we need to decide what to do with them. We have 2 negative numbers. So both of these numbers have the same sign. Since they have the same sign, we have to subtract the absolute value. The absolute value of -5 is 5. The absolute value of -2 is 2. 5 minus 2 is 3. So the distance between the endpoints and the length of line EF is 3 units. For our next example, we're going to find the length of line segment FG. If you would like to do this example on your own, pause the video here, do the work, and then unpause when you're ready to go over the steps and learn the answer. Here's our line segment FG. To get to F from the origin, we have to go 2 units to the left and 2 units down. That gives us the coordinate -2, -2. To get to G from the origin, we would have to go 2 units to the left and 6 units up. That gives us the coordinate -2, 6. Now that we have identified the coordinates of our endpoints, we can find the distance. If we look at the X coordinates in both of our points, we have a -2 for the F and -2 for G. If we look at the Y coordinates, we have -2 for point F and 6 for point G. We're going to ignore the coordinates that were the same and focus on the coordinates that were different. In this case, our Y coordinates are different. We have a -2 and a +6. Since the two numbers have different signs, we're going to add the absolute value. The absolute value of -2 is a +2. The absolute value of 6 is +6. Add that together, 2 plus 6, that gives you 8. The distance between F and G and the length of line segment FG is 8 units.